1 cup of coffee takes 140 liters of water. A hamburger takes 2,400 liters of water to produce. In South Africa, the wastage of food is 10 million tons of food per annum. If you translate that to water, it's a lot of water. We are the 30th driest country in the world. We only receive 495 millimeters per annum. We irrigate just more than 300 million hectares in the world. 80% is still gravity irrigation. Now, smart irrigation came about 5, maybe 10 years ago when people were thinking differently.
It's really remarkable. Irrigation is a story that is both ancient, but also very new.
You see, by the year 2030, which is 5 years away, we will have a 17% gap of water availability.
Hello and welcome to this episode of the Safripol Water Security Engagement Forum. Agriculture remains at the heart of our economy, and the pressures of climate change and water scarcity certainly demand solutions. Smart irrigation systems and advanced plastic technologies such as drip systems and mulch films are proving vital in improving efficiency, protecting resources and ensuring long-term sustainability. I'm your host, Michael Avery, and today I'm joined by Felix Reiners, a professional engineer registered with the Engineering Council of South Africa, to explore how these innovations are redefining the future of farming. Felix, it's great to have you on the show. Maybe you could just kick us off by taking us all the way back into your professional journey and history, because I believe you've been in the space for over 4 decades.
Thank you very much, Michael. It's a real pleasure to be here with you. Yes, I've been involved in irrigated agriculture since 1979. So it is a long time. I've retired 5 years ago, but I'm still busy assisting irrigated agriculture in South Africa and abroad, because I'm also a president honoraire of the International Commission on Irrigation and Drainage with head office in India.
Wow.
So I'm still traveling to different parts of the world to assist and to share concepts and ideas.
There's no such thing as retirement, Felix.
Well, no, that is true.
Now, I mean, you've been in this space for longer than I've been alive. I was born in 1980, but I want you to take us back even further to maybe sketch the history of irrigation in agriculture, because clearly we've been farming crops for many thousands of years before we bring it back to today and talk to some of the more modern methods that we're now using.
Absolutely, Michael, yes. Well, it goes back to 6000 BC and called to mind, of course, Mesopotamia. But irrigation was first sort of introduced or used in Egypt. But Mesopotamia, they took it a step further, and that is where irrigated agriculture actually started, with all the old technology, with surface irrigation. Mm-hmm. And of course, that spread it all over the world. But it remained surface irrigation because there was no, you could say, technology available for distribution of water. Of course, there were some equipment developed, like the shadoof, which they used to get water out of a canal or out of a well, to lift it a little bit higher to irrigate the fields. And if one look at the present day irrigation, 80% of all irrigated land in the world, and we irrigate just more than 300 million hectares in the world. 80% is still gravity irrigation, or flood irrigation as many refer to.
Which is what we used 6,000 years ago.
Absolutely. And of course the techniques have changed. The principles stayed the same, but they use it more efficiently. And of course, only 20% is equipment-based at the present moment.
Now, on that point, I mean, obviously we want to move towards more than being, 80% using the old methods, even in a more modern way. What did those old methods mean in terms of the efficient use of water, and what impact did that have on agriculture?
We must also realize that in those times there were so much water available. And then I'm talking about the population at that point in time. So there was more cubic meters per person per annum available, so to speak. And that is part of the way that they just let the water run over the fields to water their crops. But due to the population growth, developing economies, that of course also brought about more efficient use of the water. So since those years, they moved to lasering the fields. They used to put water in pipes to convey that to the edge of the field. So there were different ways of dealing with that. And if one brings it to, maybe before I say that, I was fortunate in 2019 to visit a scheme in China, which was developed 256 BC, 750,000 hectares, one scheme, all gravity irrigated, still operating today. But they transfer, or they are rebuilding that with the use of drip irrigation. And if one comes to South Africa, of course, since 1600s, we irrigate also with the supply of food, people going past with the ships at Cape of Good Hope.
Yeah.
Vineyards were planted, but the first recorded history is only in 1875 when we know of structures that were built, but also gravity irrigation was used in those days.
It's really remarkable. Irrigation is a story that is both ancient, but also very new, because just in the last, would you say, 100 years, we've really started to see a ramp up in innovation and the way we use water more efficiently, because we've had to.
That is true. And you could say irrigation with the utilization of equipment is a young industry. If I'm saying young, the very first sprinkler was only developed by a farmer in 1933 in Florida, United States, to irrigate his citrus trees. But you had to build it with steel, with springs. It's almost a pre-sprinkler as we know it today, but it operated and irrigated. But it was only with World War II when material came about. And then I'm talking of steel and of aluminium pipe. And of course, as you know, polyethylene was only discovered accidentally, for instance, in 1933, the same year as the first sprinkler was operating. And from there it developed. 1939 it was commercially produced, and the agriculture was transformed, irrigated agriculture, with the availability of pipes, which is the steel pipe, together with the polyethylene pipe, and that was the low-density polyethylene pipe. It was only later years when we had 1953, when high-density polyethylene pipe was produced. And the agricultural sector utilized both of these type of pipes. So there's a huge growth in the last couple of years in the concept of drip irrigation.
Right.
So from flood to sprinkler, and then of course 1949 the very first center pivot was developed, also by a farmer. But the very first commercial one was only sold in 1953. And since then, it took the world over. In South Africa, for instance, we got the fourth largest amount of center pivots.
Wow.
And apart from the steel, there's a lot of plastic or polyethylene utilized in terms of the sprayers, in terms of the nozzles, in terms of the piping, even the pump houses, where they formerly used steel as part of the network or the building of the pump house for getting the water from the river basin to the pump. They are using now polyethylene as a way of transporting the water to the center pivots.
Why polyethylene rather than steel? And then maybe you can just talk to us. Many of us would have done a road trip through the Free State or one of the, the high density farming areas of the country, and you see these giant sprinklers over the land. So maybe you could just explain what a typical drip irrigation and an irrigation scheme would look like on a big commercial farm.
Yeah, no, a big irrigation scheme, of course, it is a lot of money in terms of the layout. But if you just take drip irrigation, it is normally where they use about 16 millimeter piping. There are different sizes, of course, 12, 16, 22. And drippers are spaced from 0.3 to 0.6 to 0.9 and even beyond that on the line, the dripper line. But if you space it at 1 meter, then you need 10 kilometers of pipe per hectare.
Per hectare?
Per hectare. Because a hectare is 100 meters by 100 meters. So that means if you space it 1 meter, you need 10,000 meters of pipe. And it costs you about 7 rand per meter. So it is 70,000 rand investment for a farmer. But they don't only irrigate 1 hectare, they irrigate 20 hectares, 30, 100. The biggest scheme, what was that 1997, which they started with subsurface drip, was Munya, where they installed it at 1.8 meter spacing. That was 12,000 hectares at that point in time. And it is still being used as the most efficient way of delivering the water to the crop. So there's a move. I've done some statistics since 1981 of the use of micro-irrigation in the world. As part of my portfolio at the International Commission, we got information from all the member countries. And at the present moment, there's more than 20 million hectares that's been micro-irrigated.
Now, what is micro-irrigation?
Micro-irrigation is a combination of micro-sprinkler and drip irrigation. Not a combination, it is both.
Right.
So the one is a dripper line with a small dripper and installed in a pipe. And then a micro-sprinkler is the one that you normally see in a garden or even at a household. That will spread the water from a small sprinkler that operates and spray the water. So it is two different types of systems, but they both use polyethylene pipe as a basis. The pipes that feed the water into the area is polyethylene pipe. With drip irrigation, as I said, is about 16 millimeters of piping, and with micro, the sizes might vary from a 40 to a 32 to a 25, and maybe at the last stretch, maybe a 20 millimeter pipe in combination with your feeder pipe and your little micro sprayer on a peck right next to the tree. Big orchards and so on are utilizing that.
And what is the advantage of using that combination and also, the polyethylene pipe?
Well, polyethylene pipe is, of course, very much convenient to utilize. In the manufacturing process is, of course, very interesting. Of course, the drippers are separately manufactured to a high quality standard, and then the polyethylene pipe is a combination of granules, which they then, about 400 degrees centigrade, they melt, and through extrusion, that drippers is then placed into the extrusion process. and they infuse the dripper inside the dripper line at predetermined spacing of, say, 0.3 of a meter.
Right.
Then it is still a closed pipe, and it runs through a cooling canals of about 30 meters. And as it exits, there is almost like a photostat machine that looks where are the drippers. And then there's a laser cutter to cut a little hole in the polyethylene pipe so that the water that runs into the pipe when it is installed can exit the dripper through that fairly high technology out and drip onto the surface right next to the root zone. So that is why it is so efficient, and the water losses are not that great. So people are moving towards that way of irrigating. But of course, our other systems have also improved in terms of their application, like the center pivots. In South Africa, we got now about 28,000 center pivots operating, which is the largest and fourth largest amount.
In the world?
In the world. America, where it originated from, Nebraska, they got more than 400,000 center pivots.
And the center pivots are those?
Those circles that you see from the air,
yeah.
Also very efficient. But of course the water have to travel from the sprayer to the soil surface, and then you might have some losses. But they still operate quite efficiently.
It's remarkable just getting that insight into what goes in to putting the food that we eat on our table.
Absolutely.
And, and where we would be without these efficiency gains that have been enabled through these new materials and new technologies and processes.
Absolutely.
Talk to me about how much water we're using in the agricultural sector, because through the series we've often had the figure bandied, 60% of our water is used by agriculture.
Yes.
Firstly, how does that compare globally? And how efficient are we being with the use of our water in the commercial agriculture and agriculture broadly in South Africa?
Yeah. Michael, yes. In terms of water in South Africa, of course, we are the 30th driest country in the world. So we do not have water. People might not think so, but we are the 30th driest country. We only receive 495 millimeters per annum. That is 50% of the world average. So if you take that on the soil surface of South Africa, it equates to about 110,000 million cubic meters of water. Now that's a lot of water. Normally you don't have
a few swimming
handle
pools.
on, absolutely. But immediately from that, about 60,000 million cubic meters just evaporate. So we remain with 50,000 million cubic meters of water, and only 8% will run down towards our dams. And we got on the register of the Department of Water and Sanitation 4,500 dams with a capacity of 32,000 million cubic meters of water. From that amount of water, 16,000 million cubic meters of water has been utilized, and that is distributed through all the sectors, the municipalities, the mining, energy, and of course then agriculture. And agriculture in South Africa, as you rightly point out, is utilizing 60% of that water.
Of that? Okay.
Of that. So about 4 years ago, Water Research Commission project was commissioned, and they used satellite imagery to determine precisely how much water has been utilized by agriculture. So they analyzed all the data. As you know, there's satellites going over South Africa almost every minute.
Yeah.
And the volume was 10,221 million cubic meters of water that the agricultural sector is utilizing. So that is where the 60% is coming from. But one will understand why agriculture is utilizing that amount of water, and that is due to the fact that to produce food, it utilizes a lot of water.
Yeah, but I think, on that point, I'm very glad you sketched that out, because often I think there's a misconception that agriculture is using 60% of all the available water, but it's only that available through the dam system. And once we've got down to that, it's not of absolutely all the available water that we could distribute in the country.
That is true.
But I want to come back to this concept of how much water we actually utilize in our daily lives, not just in agriculture, but our water footprint more broadly. There's this concept you were talking to us about of virtual water, which I think is fascinating.
Yeah, virtual water is, of course, a very interesting concept. Research started way back in 2005, mainly in Europe. And at the present moment, our universities here in South Africa, I'm talking of almost all the universities, collaboratively or individually, they are doing research on that. And virtual water is the amount of water used to produce something.
Yeah.
And that could be food, that could be this building. And what they did for food to find out what is the amount of water needed to produce food, all the different food stuff. For instance, a cup of coffee that everybody loves to drink takes 140 liters of water.
Remarkable, because most people would probably say, oh, you look at the cup, it's maybe 300 mils. That's
right.
the...
Yeah. But they don't realize that somewhere there's a farmer planting a coffee tree. It took 3 years before they harvest. Sugarcane farmer the same. They apply 12,000 cubic meters of water per hectare.
Wow.
Then they produce 100 tons of sugarcane. And 10% is the sucrose, or the sugar. So if you convert that amount of water to the sugar, and then you put 1 teaspoon, maybe 2 in your cup. So and of course the little cow was born somewhere, have to graze, have to drink water. Only 2-3 years later produce milk, and that all counts up to the volume of water of 140. But what will even amaze you is a hamburger. A hamburger takes 2,400 liters of water to produce 1 hamburger. And that is why our parents or our guardians will tell you, you must clean your plate when you eat.
Don't waste your food, because you're wasting water at the end of the day.
Absolutely. And South Africa, the wastage of food is 10 million tons of food per annum.
Wow.
So if you translate that to water, it's a lot of water.
Yeah. And it also shows you, doesn't it, Felix, the interconnected nature and the nexus of all of these things, of water, absolutely, of food, of agriculture, of energy, the energy inputs in all of these processes, absolutely, as well.
Yeah.
So when you look at it, and someone asks you, what do you see as smart irrigation, and where are we seeing signs of innovation and improvement so that we can do more with less?
Absolutely. Now, smart irrigation is, of course, something also that came about, you could say, 5, maybe 10 years ago, when people were thinking differently in terms of application, in terms of technology, in terms of that nexus you are talking about, the water, energy, food, because they are interconnected. Because you need water for the food, you need energy to pressurize the water for the system to operate effectively. And there are very, I would say, high norms and standards that myself were involved in establishing for the irrigation sector through the South African Irrigation Institute, through the Agricultural Research Council, to establish norms how a system should be designed and operate. So that is imperative in terms of how you should operate your system and distribute your water over the field, so it is effectively, so that each plant receives the right amount of water. And we talk of the beneficial use of water. So we did a 4-year research on water use from dam wall release to root zone application. Different disciplines work together, and we established norms in terms of what is happening when the sluice is opened at the dam and it runs down the canal, and then the offtake to the farm gate, and then from the farm gate into the pump and then into the system. And we also measured what's happening into the soil. So a lot of things were measured, and from that one could see what is the best practice to find out what is happening in the soil, what is happening in the pipeline, what is happening in the canal. And South Africa are very fortunate. We have won several prizes internationally in terms of the way how we manage our water by means of a water administration system that has been developed by our engineers and people that monitor the water through a whole series of measurements. There are technologies that has been innovated in terms of managing the water from the pump house onto the area of the where the crop has been planted. So a lot of things, and of course cultivars also been developed to be more, you could say, drought resistant. Yes. So less water is being utilized.
Yeah, yeah.
And the whole principle where the world is moving is towards water productivity.
Rather than efficiency.
Rather than efficiency, yeah, absolutely right. So efficiency is anything, if we talk efficiency, it is what goes in and what you get out. Then they get a comparison between those two, and they said it is so, that percentage efficient. So it might be a 60, a 50 or 100% efficient. But irrigation, normally gravity irrigation, is regarded as about 70% efficient. Some people would say, no, it is 30% efficient because you use too much water. But if you do it right, you can achieve. I've seen in the United States, in China, various ways how they do it absolutely right in terms of lasering the fields, in terms of bringing the water right to the irrigation beds. And therefore they improve the efficiency with the water coming in and how much has been utilized. But of course, your drip irrigation, your center pivots, where products are used to distribute the water, is much more efficient in terms of the in and out. But that is efficiency. The way the world is thinking or is doing it now is to look at productivity.
Productivity.
And that means how much water are you using to produce so much kilograms or tons of a certain product. So you will then say, I have utilized 11 liters of water to produce one tomato, for instance.
Right.
Or I've used so much water to produce one apple. So people start to think more in that direction and applying that principles.
And maybe you could just talk to us about why we've shifted in that direction. Does it allow us to better understand the resource
Yes,
constraints? And
absolutely.
also, are we seeing, in terms of the measurements, are we seeing improved yields, better water utilization through this approach?
Yeah, absolutely, because water, as you know, in South Africa are legislated, Act 36 of 1998. So a farmer must have a license to irrigate. They cannot just utilize water, and they are only allocated a certain volume of water for the hectares that they applied for. And therefore, farmers are looking at ways and means to optimize that water. And one way is, of course, to get the maximum yield per liter or per cubic meter of water. And that brings a totally new economy about in terms of how people are thinking and we are using. Because South Africa, as I said, is the 30th driest country. And the prediction moving forward is by the year 2030, which is 5 years away.
Yeah.
We will have a 17% gap of water availability.
Versus water demand.
Water demand and water availability. So that is frightening, and we should be looking after our water resources.
Yeah, and it's also exciting on the other hand, because this creates opportunities, surely,
Absolutely.
for new industries, new career paths, professions. Are you seeing that from where you sit and a lot of the work that you're doing at the universities?
No, for sure that is happening. Not only from the farmers that are operating these systems, but also the designers, the advisors assisting with measurements, utilizing of satellite technology, drones, many techniques, even the research that's happening at universities and at the Agricultural Research Council, looking at different ways to optimize the water, to use less water per crop that you irrigate. But it remains a challenge.
Aerobotics is a great company. Drone technology, you know.
Drone technology, vertical agriculture that you see is the way it's going to the future. But you cannot produce all crops on a vertical basis. It is only certain crops. So you still have to plant your maize in open field, either by means of rain-fed or by means of irrigated agriculture. So because we need bread, we need our wheat to be planted in open spaces. But other crops, of course, yes, we can do aquaculture or hydroponics or vertical agriculture.
And then also hope that the weather plays its part as well. And I know we've been very fortunate to have quite rainy and conducive conditions, especially in the maize growing regions of the country, but we are probably due for a drought. And with that gap that you're talking about, it's urgent that we find better ways and better collaborative partnerships. I mean, how important is partnering in this space between policymakers, government, researchers, experts such as yourself in the private sector in order to drive this forward?
They refer to it as PPP, private partnership and public sector coming together and working together to find solutions. So that is very important, and it is slowly happening more and more in different ways. We see it in the municipalities, we see it in the agriculture, where people are working together. Our water user associations is totally privately driven, but they still need the expertise and the collaboration by the public sector, because water has been privatized. So the water supply has been, you could say, managed, even our dams, by the Department of Water and Sanitation. So we need that collaboration all over the country, and for that matter, all over the world.
That's encouraging. Is there anything missing from the current approach that you would like to see more of?
I would say one would like to see more, you could say, expertise be part of that algorithm or that working relationship. Because what one happened to see, what's happening in many places is that they are lacking of skills in terms of managing those schemes. The private sector, of course, they employ people that assist and make use of newest technologies that optimize the water use.
Just as we wrap up, and you know, for our curious South Africans out there, Felix, if even those, I think, in peri-urban areas, rural plots, or if you live in the city, I think we feel the impact of water quite differently from the way you do on a farm. But are there affordable entry-level kind of smart irrigation solutions out there that we could start deploying at scale outside of what we've discussed for the big commercial agricultural concern?
Yes. I don't think we know exactly how much, you could say, irrigation is taking place in urban areas or in the backyard of people. Because that is where people also are addressing food security. I've been involved in a project now for the past 3 years where we actually installed water tanks with rainwater harvesting and with drip irrigation for households just to produce some food for the table. And the same technology that are available for the commercial farmers, we use that for the households. just on a smaller scale. Obviously, you need some inside knowledge, and that is where we did some training. And there are a lot of information available that you can find and get hold of from our irrigation companies and even from the South African Irrigation Institute or from the Water Research Commission or from the Agricultural Research Council that provide household technologies that can be utilized. And I've started way back in 1980 when I moved into my first house, which I built myself, to employ flat irrigation, gravity. And then I transferred to micros and then to drip.
Well, there's nothing like
still operating.
Yeah, and growing your own vegetables at home and having that efficient use of water at home as well.
Yeah.
Would you mind if we shared some of that and the resources on this portal here in the Water Security Engagement Forum portal so that we can share it more broadly?
Absolutely. No, you can. You are welcome to do that. Yeah. No,
fantastic. Felix Reiners, thank you very much. It's been a great pleasure sharing your insights into the world of irrigation, which quite clearly is one that's fascinating, evolving very quickly and holds great promise for the future, and clearly one that is highly reliant on new materials, new ways of thinking and new ways of doing things to meet the demands of future farmers and future populations who rely on the farmers in order to eat and to sustain life. Thank you very much.
Absolutely. Thank you very much.
Well, in a world where water is growing scarcer and food demand is only rising, smart irrigation is moving from innovation to adaptation. And as we've heard today, plastic isn't the problem when used wisely. It's really a big part of the solution. From drip lines to mulch films, we now have the technology to grow more with less, to bring precision to the unpredictable and to secure food without sacrificing water. A huge thanks to Felix Reiners, a true pioneer in the field, for sharing his knowledge and his passion. And to you, thanks for tuning in. Whether you're a farmer, a policymaker, or just someone who values the food on your plate, remember, sustainability starts in the soil, but it's delivered drop by drop. This has been the Safripol Water Security Engagement Forum with me, Michael Avery.